Hey everybody, welcome. This is the Intro to Actor Framework presentation. Everything you want to know, but we're too scared to ask. We are Casey and Dan.
Yep, my name is Casey May. I'm a co-founder of Zyah Solutions. We're a small LabVIEW consulting firm based out of the San Francisco Bay Area. I'm a LabVIEW champion, a certified architect, and an embedded developer for LabVIEW. And I've been using LabVIEW for about 20 years now. I've also been using Actor Framework, probably apropos for this presentation, since about 2014.
Yeah, and I'm basically the same person, all the same stuff. Same t-shirt, whole deal. So what we're here today to talk about is the Actor Framework, right? It's one of the most popular LabVIEW frameworks. It ships with LabVIEW. You've got it on your computer if you have LabVIEW. And we should really probably cover that in our presentation, or else, NI's not going to invite us back to talk again. But before we do that, what is a software framework in the first place? We're kind of throwing that term around, and I wasn't sure what the definition was either. So I went ahead and plugged it into Google and got the AI summary response, which was almost surely wrong because it's an AI summary response. But I liked how it sounded. I tweaked it a little bit, and the definition I have here is that a framework is a structure or blueprint to guide your code, right? It's not your code. It's not some reusable driver that you're going to use. It kind of gives a structure to your code. It standardizes practices of how you're going to develop and how your code's going to function internally. It utilizes reusable code. So that seems important. You don't have to write everything yourself. It wouldn't be a framework if you had to do it. It provides tools to make your work easier. So the reason you're using a framework, part of it, is to make it so that you can be more productive and do a better job. And it allows you to develop, harder, better, faster, stronger, taking you from Mr. Bean to the really cool Daft Punk robots. Clearly, they're better programmers.
Oh, so Dan, right?
Yes, Casey.
So frameworks are cool. You sold me on that. I should probably just write my own framework and use it at my own company, right?
No, don't do that. Get off the stage. That's the last thing you should do. Don't roll your own. There are frameworks out there. They are put together by someone else. Utilize their work. They're tested. They're scalable. They're maintained. There are tools built in to make your life easier. There's training material out there. Not only the official training material from NI, but people in the community are making videos for how to use Actor Framework. You can go look at the great Tom McQuillan ones that he posts online. They're awesome. And they're understood, if you use a framework that's common, it's understood by people outside your organization. So if you need to bring in someone to help you with your code, there's a good chance you can find somebody who knows how to do that. If you're writing your own architecture and your own framework to start off with, no one outside your group is going to know how that works. And if you want to educate new developers, you're going to have to make all the training material. When bugs come up, you're going to be the one who has to fix them. All that stuff. You have to put all the tooling together if you want to do scripting to make it easy for people to do things. So don't make your own framework. Stick with something. And I'd recommend the Actor Framework. I like it a lot. Fundamentally, what it is it's just a way to launch some loops and then send messages between those loops, right? That's what it boils down to. You're trying to do that in your application. The Actor Framework has been included in LabVIEW since 2012. It's really powerful, it's really scalable. And when we're talking about things like loops, there's all sorts of different terminology you can use in your application. You could call them processes, you could call them modules, but you can call them actors, but really it's just some functional part of your code that's going to be sitting there continuously running and doing stuff, right? You want your application to do stuff. It might be your business logic is something you could call it. And then messaging in LabVIEW, there's obviously a lot of ways to do that. You can use queues, you can use events, you can use notifiers. And the advantage of using a framework is you kind of standardize on something so that you have kind of consistent communication between your different loops or actors. Yeah, so it's object-oriented, which is good to know, but you don't necessarily need to care. So we're gonna do a demo today, and we're gonna put together some actors for you, and we're not gonna get too tied up in any sort of object-oriented terminology. We're just gonna show you how to do some stuff. There we go.
There we go. All right. So about this time, you might be thinking to yourself, hey, a way to, like a loop that's running, a way to send messages to it. I think I know how to do that, right? And the thing that everybody probably starts out with, or something that you learn very early on, is the NI queued message handler. So let's dive a little bit into that and how that looks before we kind of transition to the actor framework. Some delicious, delicious spaghetti coming up. All right, so here we have the block diagram of a typical queued message handler. There are a couple points or a couple structures on here that I want to point out. First, we have this loop at the bottom. This is the loop that Dan was kind of referring to, the one that actually does stuff. It receives the messages, and it executes the code and the functions associated with those messages. This we can call the message handling loop. If you wanted to run this module, actor, whatever you want to call it, queued message handler, if this is a top-level VI, often you can just hit the run button, and this will launch that loop. And finally, there's the way that you talk to it, or in queue messages so that they are later processed and executed, is via a message. In this case, we have an event handling loop, which is showed up at top there, and inside there's that VI, which is in queuing a message. You see it takes in a case, that display text string, and the input associated with it, that text input there. Okay, so that's great. You have a nice, simple queued message handler. But what if I want to add things to it, right? What if I want to do some data acquisition? What do? I need another loop, right? And if I want to communicate with that loop, I need another queue. If I have data, maybe I want to do some processing of that data, right? I don't just want to throw away the data. I want to do something with it, maybe some calculations. I need another loop. Now that I have that, I've done some processing, I want to save that data. I need something that logs this. So what does that mean? Another loop. What happens if I have more than one instrument? Maybe I have actually multiple copies of the same instrument and I want to acquire data from both of those or all of them. I need more loops, right? So how do I handle this now? Each loop you communicate to it through its different queues. So what do? Maybe you bundle that information, those queues into the cluster and the module data. You see that cluster there that's on the shift register. Let's see. But what I do this all in one big VI? What if I want to start or stop modules at different times? I don't want to launch them all when I hit that run button. Maybe the logging I only want to have at a certain time. How do I do that? Because if I start that, then how do I ensure that the rest of the code runs? So what if a developer wants to work on one part of the code here, or one case, one of those functions, while I work on another section? How do I do that? Everything is kind of like if everything is on one big block diagram. So, it looks like we end up with a lot of spaghetti code here, right? A lot of wires, a lot of everything going on the same block diagram. So there's got to be a better way, right? So some of the problems that I just mentioned in looking at that example where you have an application that starts simple and starts to grow and grow and grow. This slide is heavily inspired by Darren Nattinger's Intro to DQMH presentation, which you might be seeing later. So communication between the loops is not straightforward. The more modules you launch, the more queues you have to manage and track. How do you do that? And this quickly becomes unscalable for larger applications if you have many, many modules, many being launched dynamically or statically. This can be difficult to debug as well, right? Because what you're putting onto the queue is just a string and a variant oftentimes. And anyone that has access to the queue can do it. It can be hard to figure out like where the messages are coming from, who sent them to that particular module or actor. Especially if you're defining the cases by a string. If you don't surround it by a sub-VI, maybe you do a string text search in LabVIEW, and it works, but it's not the greatest. Also, a big one, I think, is that the messages themselves, the data that you input on them, are not type safe. So, which means that people are probably familiar again with that string and variant combination, that cluster that gets put onto a queue. When you are unbundling that data and translating it back to the data that you want, if you happen to have put the wrong data into the queue and now you try to convert it into something that it's not expecting, you will get a runtime error. But you only get that at runtime. You can't catch that up front very easily. There's limited reusability with the NI QMH. Modules are often tightly coupled to another. If I have that module, that queued message handler that I showed, and I launch a logging module, or I launch a DAC module, and maybe that DAC module is now wants to do some logging and it calls the logging module, I can't reuse the DAC module on its own. It needs the logging module to come along with it. And maybe I don't want the same behavior in another application that wants to reuse it. There's also no mechanism in the standard NI QMH to support multiple instances of a QMH running. So I mentioned maybe you have two copies of one instrument. And it's the same instrument, so you want to reuse the same code, but it's not obvious or easy to have two copies or two instances of that running at the same time. And finally, adding new functionality to your producer and consumer loops or that code is often, or it can be error prone, and it's also tedious, right? You got to add new loops or new cases for the different functionality. You got to type in the string for the function that you want it to execute. If you have a typo, you're going to run into problems. And you got to do that for every case you want to do. There's no tooling around it to help you do that in an automated fashion. Any questions so far? Kind of assuming that everyone has some familiarity with NI QMH, so I think hopefully this is just pointing out problems that you already know.
Cool. All right. So assuming you do have some familiarity with the kind of NI QMH template code, we're going to show how you kind of convert that to an actor. It's going to be a lot more flexible, scalable, and importantly, pet-friendly. So you're used to seeing this on your block diagram, right? One big VI, you open it up and you can see what's going on. A little bit that's different about the workflow with Actor Framework is that instead of looking at this one VI on disk where you might have your loop, what you have is a library in your project with message classes and then an actor class with methods that get executed. And there's some advantages to this. So if you ever worked with more than one developer, by sort of breaking it up into different files on disk, that makes it a lot easier for people to work on different parts of the code at the same time. And even if it's just you and you're the only developer working on it, when you are making changes to your code and making changes to your actor, and you're using source code control to keep track of what changes you're making, it's a lot easier to tell what's going on when you're doing it file by file rather than changing the one big VI where everything happens. So messages, we saw the queued message handler there. We're basically taking a string variant pair and we're plugging them onto a queue. And actors, very similar, but what we have is a send method. So for every message you can send, there's a method you can do it, and it takes only the right kind of input. So there's no way to send a message with the wrong string matched up with the data or the wrong data for it. So the messages are type safe, so you're always going to have the right data included with your message. Also, by having them set up this way, it's a lot easier to find the file in disk. So if you want to say, hey, which other parts of my code send me the display text message, you can search for that VI and find everywhere where it's being used really, really quite easily. And when you use the scripting tools in LabVIEW to make the actor message, you actually end up with a message class and then some other files on disk. The one that's important is the send VI. So right there is highlighted send display text. It's included with some other files to make the framework work, but you don't really have to look at those at all. What really matters is that just for each thing your actor does, there's a message, you can send it. And that's a single VI. Next part is the loop. You're used to seeing a loop like this. Loop, case structure inside, things are getting dequeued, and they end up as different cases. The loop in Actor Framework, you never have to write the loop ever again. So the Actor Framework code itself gives you the loop. You've never got to make the loop, you've never got to resize how big the case structure is, make sure your stop terminal is lined up the right way. It gives you the loop for free. No coding required. Then you've got the loop, that's important, but what's more important is what the loop's actually going to do, right? There's things you want the different modules in your code to do. And what we have there, instead of the individual cases in the case structure, each one becomes a VI on disk. And lots of times we refer to those as payload methods. So you send a message, and then what gets run is a specific method. So send a message, execute a payload method. Those are all the things that your actor can do. Launching the actor, there's a VI that ships with the Actor Framework for that. So you just wire in your class and call the launch VI. Boom, your loop is now spinning. It's up and running. You can launch multiple copies of it, all the good stuff like that. Again, reusable framework code. You don't have to write it. And when you do the launch, what comes out is that wire, which is called, in Actor Framework terminology, it's called the enqueuer. And it's not quite a queue, but the best way to think about it, I think, is just to think about it as the address. You launch an actor, and what gets spit out is the address for that actor. So when you send it messages, if you remember back from a few slides ago, that was our send message. What gets wired into there is the address you want the message to go to. So it's as simple as that. All right. And now that we've covered kind of what the pieces are, we're going to dive right into a live demo and show you guys how to make some actors.
Bear with me here while I try to figure out how to code on this stage, given the setup that we have.
Physical constraints.
Yeah, maybe I can use the mouse up here. They didn't tell us how small this was going to be. Any questions while I'm trying to get this set up either?
Yeah, so out of the audience here, who's pretty familiar with the queued message handler kind of setup? Cool. And who's actually used Actor Framework before? Okay, smattering of hands.
Actually, I can do this. All right. So I'm going to open up a small application. It's the code that you kind of saw on the block diagram there before. But what it's going to do, I'm going to run this. Everyone can see that more or less, I'm hoping. This is a queued message handler, an NI queued message handler. And what it does is you can enter some text in this field here, and when you click on display text, it shows up in that message box up there. So if I say, welcome, if I could type, set display, it would just append it there if I keep clicking. Yeah, ignore the typos, please. So anyway, let's take a look at the behind the scenes. Again, this is stuff that you're probably mostly familiar with. Let me see if I can change the resolution a little bit here. So we have our standard queued message handler, the parts that we talked about, the message handling loop, the event handling loop. This is where when I click this button, this display text button, the message is enqueued here via a string and another string input here. If you can see there's that red coercion dot, which means that it's being translated into or converted into a variant, so that when that message is dequeued down here in the message handling loop, the variant comes out, you change that into a string. That message that you entered in that text box is appended to the existing message buffer, and that's updated via, in this case, a property node. So fairly simple, fairly straightforward. Let's take a look at the same application written in Actor Framework. So, all right, so I'm going to run this. As we mentioned before, there's a launcher which just launches the VI, but exact same behavior. If I type stuff in here, it shows up. So functionally equivalent, right? Let's take a look at how that translates on the block diagram and how it looks similar or different. Again, the message handling loop, that's inherited from the actor class. You get it for free. You don't have to write that loop. It's just this VI that's right here. You don't have to think about it other than that. You have the same event handling loop where you click on this button, this event fires, and this VI comes with the Actor Framework. It's something that ships with it. Actor Framework ships with LabVIEW. This is getting the address for this particular actor, the one that's running. And you're saying, send this message of displayed text with the input of text to itself. And then on disk, there's a corresponding VI, which matches up with this case here. Same thing, with a couple key differences. One, you can see instead of this cluster that's on the shift register, it's replaced by these actor classes that go in and out. For all intents and purposes in this demo, you can think of them as pretty much the same thing. It holds information that you can unbundle, and you can bundle information back to it. So it's holding onto that message buffer. And you can see it works the same way here. You're unbundling information and bundling it back up. And then it's updating information again via a property node in this case. The key thing that we pointed out before, but you can see here, is that this is not a variant, right? It's a string. So you cannot wire anything but a string data type to this input. If you try to do it if you tried to do something else, you would get a broken run arrow at edit time. So you don't have to wait to run the code and have potentially something bad happen when you're executing or with the wrong type of data. You know immediately. Let's see. Yeah. So that's kind of the application, the equivalence between two applications written in NI QMH and actor framework. But we said we're going to teach you how to write a new actor, right? So if you think back to that example we had before, one of the things we said might be handy is to have some sort of data acquisition, right? So why don't we create a data acquisition actor, and what it'll do is send some information back to this actor and display it in this message log. So first thing I need to do to create a new message, I don't have to install any other packages or anything like that. All I need to do is right-click on your target, in this case, my computer. If you say new, you've probably seen this before. There's some options here, classes, libraries. One of the options is a new actor. So if I click on this, it pops up with this dialog. I'm going to call this a DAC actor, creative naming. And once I say OK, if you look at the project, there is a new DAC actor library in my project. It's already saved to disk. You're ready to go. And what this library contains is the new DAC actor itself. That's the loop, right? The library that contains the loop and the methods that can be executed in that one, as well as a folder for the messages for this actor. And if you remember, the messages are just the way that other actors or other code can interact with this actor. If you're familiar with the term, you can think of it as the API. So I have a new actor. If I want to launch this actor now, all I need to do is I can, sorry for not using quick drop here, Darren, but it wires it funny, so I'm not going to. In the data communication panel, there's actor framework. Why don't I leave this pinned up? There is this VI called launch nested actor. Launch nested actor takes in the existing actor, and then the input here, do I have context help? Visible. It also takes in this nested actor. That's the actor that you're launching from this particular actor. So in this case, I want to launch the DAC actor. And all I need to do is wire this in here. And that's it. That's all I need to do to launch this actor. I notice now, because the actor is a library, or is a class, which is a type of library, it has this nice header here to identify it. So if I go in, I can go into the properties of this particular actor. I can edit the icon. And I'm going to just type DAC here. So anything I created related to this actor is more easily identifiable. It's a nice way to kind of visually just see that I have new things related to this actor. And now, if I were to run this at this point, everything will still run. So this application is going to behave the same. I'm going to be launching another actor, which is another loop. Currently, it doesn't do anything else. But what I want to show you here is, so again, I can display text. When I shut it down, the actor that I launched automatically shuts down with the rest of the application. By default, whenever I shut down an actor, any actors that it launched will shut down automatically, which is nice. You don't have to worry about calling code to shut it down manually, making sure that happens. So that's nice, but now I actually want to do something with this actor, right? The DAC actor isn't very useful if I'm not actually performing any data acquisition on it. So let's implement that now. So in order for the DAC actor to be able to send information back, it needs the code in order to do the acquisition. So I'm going to add that now. I'm going to right-click on the actor, say new. You can choose a lot of options here. You've probably seen again, VI, virtual folder. For actors, I'm going to choose this VI from Dynamic Dispatch template. And the main difference here that you can think of is that it's added these actor inputs and outputs in the top left and right corners respectively. Right? And that is, again, if you recall, the QMH. Whoops. Here, let me save this first. I'm going to call this acquire. It basically just adds this extra wire in here so you can unbundle and bundle things if you need to. I'm going to give this VI a nice icon. So now it says acquire. It's easy to identify. I'm going to put the code in here to actually do acquisition. So I don't have hardware, right? If anybody has any questions, feel free to jump in at any time too. So I'm going to say, where is the quick drop? Oops.
Got a quick question.
Yeah.
The actor that launches the reactor,
Let me give you a
does have access to. If you launch an actor via an actor, the child actor, does that have access to all the methods or VIs of the parent actor?
I'll answer that. No, so if you launch a nested actor, that is just a completely separate actor. It has nothing to do with the parent one necessarily. It just has a launching relationship. It doesn't have any sort of like inheritance relationship or anything like that. You can set them up to do that if you want, but it's something you have to take another step to do.
Okay. All right, so I'm just going to take the date and time and seconds. I'm going to perform a sign operation on it, and that's the information I'm going to feed back to the calling actor. You can see it doesn't expect a timestamp here. It needs a double, so I'll just insert that there. It's really bugging me that I can't see the quick drop window, but okay. So I've inserted this display text. We saw originally that we were using this message on the main actor. That's how we were sending it the message to update this indicator here. I'm reusing it in this stack actor to send it. So if I wire things up here, and again, this is demonstrating the point. There's a broken wire because I've wired in a double, a numeric, instead of a string, and it's expecting a string input. I can't accidentally wire in the wrong data type. So what I can do though is insert format to string. Geez. Coding like this, looking up on the screen is more difficult than it looks. Okay, so that's just taking in a floating point numeric, converting it to a string. So the last thing I need to do is I need to, if you recall, it takes in the input for the message. You need an address, right? So I want to send this to the calling actor. The calling actor launched this DAC actor. That's referred to as the nested actor. The nested actor, the relationship back up to the actor that launched it, that's the calling actor. So, oh my gosh. Actually, I'm just going to use the palette. In addition to reading your own enqueuer, you can also read your caller enqueuer. So if I just wire this up here, that's another reason you need this wire. Once you wire that in, you get the address of your caller. You wire that in, and that's all you need to do. So instead of the case, modifying the case in the message handling loop, I just have written a new VI, and now I have this.
But this is kind of what I was saying, that the child has access to the parents' display text function. That's kind of what I was saying.
So the child,
okay, yeah, so I was sort of misunderstood the question a little bit, and I was thinking about a different kind of relationship. When you launch an actor, they basically have access to two addresses, their own address and the address of the actor that launched them originally. So yeah, this new actor that Casey has written has access to the address of whoever launched it. It doesn't necessarily know who that is, but it has that address, so now it can send it a message.
All right, so now I do that. One thing I forgot to mention that I have to do as well is I have to create a message for this method. So this is what actually executes, what we're calling the payload method, but we need the equivalent of this message for that message, correct? So again, there's built-in tools to help you do this. You don't have to create the class or anything yourself, the class message. All you need to do is right-click on the method. There's an active framework menu here. If you click on create message, this is all scripted. This is included for free. It automatically creates the class, puts it into this folder that I had alluded to earlier, and there's this acquire message with the associated send. And again, send is all you really care about. The other stuff is necessary for it to work, but you don't have to look at that code. So Last thing to do, I have the message. I need a way to call it from this application. So I am going to just duplicate this button here. Did I spell that right? Maybe, sure. So now I have an acquire button. I'm going to add a new event case. This is all stuff that you would do in a QMH anyway. So when this button clicks, I'm going to acquire. I want to send it the acquire. This takes no inputs. It just executes that message. And what do I need? I need the address for the actor that can execute this message, right? One of the outputs when you launch a nested actor is that actor is in queuer. So I have the address right here. If I just wire it in, and now this is in the way. Okay. That's all I need to do. If I run this application now, fingers crossed, I can still display the text. If I say acquire, it's executing that code that I wrote in here. I can even probe it to make sure this is the same thing. So you see this. So when I acquire, no tomfoolery here. It's actually displaying the message that was acquired. Oh, that's the time. So some tomfoolery. There we go. So great. We've now written a very simple actor, launched it, created a message that we can write to, and it's communicating to this actor via button click. This actor, when it's executing code, is sending information back to the calling actor. So we've created a new actor and they're communicating with each other. Great. So that's really the basics of creating a new actor in Actor Framework. You can see it's not super complicated, right? I feel like I'm gonna go on a limb here and say that if you can understand the queued message handler, you can write a simple Actor Framework application like this. It doesn't have to be intimidating.
So I do have a question.
Yeah.
So actually this started very easy, but similar to a lot of YouTube videos, I lost it again. So, 2 questions.
Mm-hmm.
You started the new actor inside another actor, but you already have a launcher. Why didn't you start both of them in the launcher?
I could have done that.
Okay.
I could have launched them both kind of in parallel.
So why did you decide to do it this way?
I did it this way just because it was easier to have the incure to talk to the new actor that I launched.
But at some point you used read colors incure.
Mm-hmm.
Couldn't you use the blue line? If you go back to the data display, why didn't you use the incure, the blue one? Yeah, that one.
This one?
Yeah.
So this is the class wire itself that holds the information. Think of it as the cluster on the shift register in a queued message handler. It's not the address. The incure is the address.
So could you get the incure from the class?
If you put it into there,
Oh.
you could. It's not explicitly put into this wire.
Sorry, and when you created a message for the acquire, how did it know what message to create?
Which message? Based on which one you have selected here when you create a message.
So the message is, so what's inside the message? Like, is it like a data type that
Is it?
defines? Yeah.
So the way I think about it is Casey created that actor down there, right? The DAC actor. He created one thing he wanted the DAC actor to do, which is that acquire VI, right? So we can see the acquire VI, the block diagram of right there. If you kind of click on it, Casey.
Which one?
Just the acquire, yeah, right in the background. So we want to run that VI, right?
Right.
And we want to say, we're going to use the original actor we had is going to be used to ask the new actor to do that thing. The way you do that is you right click on the method you want it to be able to do, right? So you get the thing you want to do, you right click on the thing and you say make a message, and then you have a message, and anyone who has access to the actors in Cure can now send it that message.
This is you can think of it as automatically creating a sub VI that does this behavior.
So you cannot call the acquire.vi directly. You have to call the message to run.
You always call it through the messages.
Okay.
Yeah, because our new DAC actor, it's not just like a class on disk you're using. It's running. It's a loop running, sitting there waiting for someone to send it a message. So when Casey calls launch VI on the block diagram there, it actually spins up a whole new loop. The loop's sitting there just waiting for someone to give it a message and give it something to do.
Again, going back to the analogy in the NI QMH, right? You're not directly copying this case structure everywhere you want that code to execute. You're instead enqueuing something, putting something on a queue. That send message is doing the same thing as this. Okay. Well, how are we doing on time? Time check. Okay. So the next thing I wanted to show is a little bit more advanced, but it goes to show some of the power, I think, of Actor Framework. So this is great. I have a DAC actor here. What if I want to have an actor that I want to reuse this, right? I want to reuse this DAC actor that I created in another application.
Yeah, I've had issues in the past where maybe a customer buys a new piece of hardware, right? And it's very similar to the previous one I was using. I'm already doing some DAC, and I want to do like 80% of the same data acquisition running in a loop, but I want like 10% to be different. Mm-hmm. Do I have to copy the code and rewrite the whole loop from scratch?
With the Actor Framework, no. So let's say in this example, I'm getting the data back. We see it's this numeric here, this as a string. But the data, maybe I decide, that data isn't super helpful if I don't have a timestamp associated with it, right? If I look back on it and I look at the data, like, when was that taken? I don't know. Whenever the person clicked it, but I have no way to map that back. It'd be useful to have that information. Now, what I could traditionally do is go into this acquire method and modify it so it has a timestamp, right? But what if I'm reusing this? Well, we said one of the nice things about Actor Framework is that it's easy to reuse these actors. You can see I can just put them down in another application, launch them, and it runs there. I may not want to change the behavior for other applications because they might be expecting what I have without a timestamp, right? So how can I do this? I don't want to rewrite everything. What can I do? So what I'm going to do here is I'm going to create a new actor. So again, we're just going to go through that same process, right click. I'm going to say new actor, and I'm going to call this DAC actor with timestamp. And I'm going to change this inheritance here. So now it inherits from the DAC actor. So I'm just browsing to the DAC actor file on disk, and I say OK. It again creates a new library with the new actor class as well as the folder for any messages. But by default right now, what happens is, because I've set the inheritance to this DAC actor, it automatically behaves exactly like this DAC actor without having to do anything else.
Yeah, we've ventured a little bit into object-oriented code terminology right there. But yeah, inheriting just means you get all the same stuff as whoever you inherited from.
So I'm going to differentiate this new actor by having a little timer here to represent a timestamp. And I can see now, I have no extra code in here. I have not written anything new. I don't have, but it's inheriting these messages. It's inheriting this behavior here, this acquire, so that if I go back to this application and I replace this, again, I can do it through quick drop, but I'm not going to. If I did this, and I just wired in this new and ran this, I still get the exact same behavior because this new actor has inherited the behavior of its parent, the DAC actor. Okay, so great, but the whole reason, I don't want it to do exactly the same thing. The whole reason I created a new actor was so that it can do something slightly different, right? So what I can do now, again, this is, if you want to create a basic application, you don't have to do this, but this is just showing some of the power, some of the advantages if you start to dip your toes into some of the object-oriented advantages of Actor Framework. I can right-click, I can say new, and I'm going to say a new VI for override. So what this is saying is I want to change part of the behavior of the actor that I inherited from, but only for this particular method. And in this case, it's going to be just for acquire. So I want acquire to behave slightly differently. So save this. Again, it starts with a kind of a blank VI here. And what I'm going to do is I want this to be mostly the same. I'm just going to grab this code here. Okay, so this would behave exactly the same, but what do we say we wanted to do? We wanted to modify this as this took in a timestamp, right? So I'm going to get time. I hope I typed that right. Yeah, so I'm going to plop this VI down that takes in a timestamp. I want to see the seconds here, so I'm going to wire that in as true. That'll give me out of this output here just the time string with seconds. So I want to add that here. So I'm going to just add this into the format string here. I added a little delimiter there just so I can see the difference between the timestamp and the data. I need to add it. This is now taking in that. Oh God. Okay. So now I've changed this behavior, right? The string coming out of here should be the time in seconds along with the data. And now I have had to change nothing else besides the fact that I'm launching this new actor with this modified behavior. I don't have to change which message I'm calling, any of that. And now when I run this, now, same behavior, when I click acquire, voila, right? I have the timestamp. So very few changes to modify the behavior. You can see how this might be powerful in other applications. Again, where you want to change like slight things, you don't want to rewrite the whole code, you don't want to make a copy of it. You just modify the parts that you need to modify, and everything still just works.
Yeah, obviously it's less useful in an example case where there's just one VI anyway. But if you've got an actor that might have 10 different things it does, you can change just one part of it. You only have to write that one code. You get to reuse everything else.
Yeah. One more thing I want to show in the demo, and then we'll kind of wrap up here, is that we talked about how difficult it is with a queued message handler, the NI queued message handler. If you have multiple instruments of the same type, how you would run both of those in parallel, right? With Actor Framework, it's super easy. So if I did this, I launched that one nested actor. Now I'm going to launch another one. Let's make it a different one. So one is going to launch the one with the timestamps. This one is going to launch just the original one that I created. I have a new enqueuer for that here. And let me close this real quick. I'm going to duplicate this event case. Sure. Call it acquire to. That's fine. And now this acquire to, which is, where are you? Here. Just move it up here. Instead of acquire to messaging that original actor that I launched, I'm going to have it message the other one. Again, this is the address for the actor that I just launched. So I can just wire that in, and now, when I do this, I get the timestamp data. If I do this one, I get the original data because I wired in the original DAC actor. And so firing up multiple actors is super easy, right? I just plop down 2 VIs basically. I plop down another one of these launch nested actors. I plop down the actor that I wanted to launch, and it was up and running, and I can send messages to it. So,
yeah, just to reiterate what we kind of talked about earlier, when you call this launch VI, it spins up a whole loop that's running in parallel, elsewhere. It's not part of this loop anymore. It's just running separately in memory, and you can message it. Yeah. Oh, mic over there.
So what does the loop VI on the top right do?
What I just said there, that it kind of spins up this loop that's running somewhere in memory, that's the loop.
But the loop is launched by the launch VI.
Yep.
So like, do you just not do anything with the loop VI?
Yep, nope, it happens all by itself. In this example here, Casey, because he wanted to have this additional loop to do user interface actions, he added to it and added on an event loop as well.
So if you're trying to like customize what happens in your loop, where would that be?
So when you want to have your loop do new things, right? You want to make new things happen, you go right over to your actor, and just like he created the acquire method, create any methods you want. So all the different things you want your actors to do in response to message, you just create more and more methods inside the actor class.
So it's not like QMH where you have cases for each message each incoming message. It's like you just create one method per message.
What would be a case is now one method underneath the actor. So it's a one-to-one mapping. QMH, case, actor, new method.
What happened though? You got a question back.
Does using the calling actors method inside of a child actor tightly couple those? So if you wanted to use the DAC actor in a different project, would that also bring over the calling?
It does, and there are ways to work around that. It's kind of beyond the scope of this introductory class. We can talk more about that if you'd like, but yes, that's a good observation.
The idea of the concept of an address, is it similar to the concept of a reference? The way we use references?
No, it's I guess closer to a queue reference, right? If you have a queue reference, you can put something on that queue, right? The enqueuer is basically the same kind of deal. Once you have the enqueuer, you can send a message that ends up at the actor who kind of spawned the enqueuer to start off with.
The inheritance of the actor, is that a continuous inheritance? Like if you change that, I know you overwrote the acquire method, but let's say you didn't. If you change the acquire method on the base DAC actor, would that change on the time string DAC actor? Or if you added a new method to the DAC actor, would that be added to the DAC time string actor?
Yep.
Yeah, so if you added a new method up there to the first DAC actor, that would totally be supported by the new one. In this new one, this acquire basically runs instead of that one. So changing the original acquire wouldn't do anything because it's already been replaced in the new actor.
But yeah, you can easily imagine a situation where you have an application where you have some like base application actor that's providing a lot of the functionality for your application. And you're like, hey, I want to add this now. And you add it into that one, and all your actors that inherit from that automatically get that behavior without having to modify code.
Yeah, and you can totally create just a sub VI in your DAC actor. That's not one. It's not the thing that runs in response to a message. It's just some VI that gets called internally, and you can override the sub VI in your child actors.
So like an abstract class.
Yep.
Yeah. So again,
totally.
we're trying not to go too much into the object-oriented side. There's a lot of good questions here. I hope that the takeaway from this is that if you want to do something simple, like very similar to what the QMH is already doing, it's really easy to spin up, and you don't really need to know that much about object-oriented programming.
Yeah, but if you want to start getting fancy, you can do a lot of really powerful stuff once you kind of get the hang of that. And I really like the fact that you can write code, and you can make actors that like, oh, I'm just going to write how I want to do error handling in one place, and have my other actors inherit from that, and they all get the same error handling. And if I want to go change how that's done, I change it in one place, and every actor in my system gets new error handling. It's super powerful when you can do things like that.
So we just have a couple more slides. Why don't we get through those, and then we can take the rest of the questions?
You switch back, I'll take this one.
Okay.
So just everything that you've shown is mostly for sending messages through strings. But if I had to be worrying about it, passing sets of data, arrays of numeric measurements or Boolean states, how would I go about that?
Yeah, exact same setup. So we had that acquire method that takes a string as an input. It's wired on the connector pane, right? You would just create a different VI that's like, hey, here, accept my big array of clusters, right? You just make that VI and then same right click, make a message. And you'll get a message that has your type def cluster as the input.
So the actor needs to be the one that holds or has that container model.
Yeah, so the method that you want to take it in, right? You need to make that the input to the VI, and then it becomes, when you right click on the VI and create the message is gonna have the exact same input.
Anything that's on the connector pane of the payload method automatically gets scripted into the send message. So then you have an input for that.
Yeah, and there's no restrictions on like what kind of data you can pass around. You can pass around, this is easy because you can see strings on the screen, but you can pass around clusters or other classes or anything else.
All right. So just a couple of concluding thoughts here. Did you want to do this, Dan, or you want me to?
Go for it.
Okay. So as we kind of saw at the end here, there's a lot of topics that we didn't get into today. We just this is the very basic introductory actor framework presentation. Big one is the power of object-oriented programming in LabVIEW. There's a lot you can get into with like abstractions, inheritance, all that stuff. There are other fundamental actor methods that you can override. Maybe when I was selecting a method for override, there were other options there. You can do things like change the default behavior of how an actor initializes or how it shuts down, that sort of thing.
Yeah, so we just showed kind of 4 methods that were launch actor, read caller enqueuer, read your own enqueuer, and the actor core loop, I guess.
Yeah.
There are more.
The message routing, we kind of talked about that when Dan was saying how the two addresses that you're generally exposed to in actor framework are yourself and the actor that called you. That kind of enforces tree hierarchy. That is nice for things like testing, and you can take like one subcomponent of the tree and reuse it anywhere. If you want to know more about that, that's about all we're going to say about that right now. Dependency management, we touched upon that too. Tightly coupling messages, depending on what you call. And that kind of dovetails into the interface messages. You can create messages in interfaces that help with that. That's a great way of doing it as of LabVIEW 2020 or later. Other best practices, we didn't really touch upon many of those. Additional tools. So again, a big mind shift or shift in the way that you think about a QMH versus the active framework is that instead of having everything on the block diagram in a case structure like you do with the NI QMH, you have them in different files in the project and on disk in active framework. And for some people that can be a little bit disorienting at first because you got to go through the project. Bowser is a tool that helps you see all the methods kind of so you can flip through them just like you could with different cases in the case structure.
Yeah, and that's an open source community tool that we put together at Zyah. So to try and help people visualize it, you can actually see your methods and then kind of see on the right-hand side, oh, this is the code that actually runs when I send this message.
Yeah. The actor hierarchy inspector, that's a tool that Alan C. Smith wrote that allows you to like open up a particular instance of a VI while it's running to help you debugging to get to the block diagram more easily.
Yeah, and having community tools like both of those, and there's a bunch of other stuff out there too, like ways to do actor communication and stuff like that. That's an advantage of using a framework that's established and other people use too, right? We're all kind of working to try and make it convenient for everybody. So it's nice to be able to kind of benefit from the whole community's input there.
And finally, I'm sure there's more that I left off of this slide or didn't remember, but the last thing I wanted to touch upon is that the actor framework is now open sourced. So NI has kindly open sourced that. So if you have improvements that you want to make directly to the framework, you can submit those, or you can look and see what issues already exist, maybe submit a new one, even submit code and a pull request against those issues, and maybe you'll see some of your enhancements or improvements incorporated into a future release of LabVIEW with the actor framework. So, and Dan and I are both members of the actor framework steering committee, as is Alan and Q, if you know him, and Tom McQuillan. So you can talk to any of us about that too.
Is this all written in C++?
The actor framework? No, it's all just LabVIEW. It's LabVIEW code running. Yeah.
Some additional resources. We mentioned, there's an official NI course, Actor-Oriented Design in LabVIEW. You can find that wherever you find your other NI training. YouTube, Tom's LabVIEW Adventure is a very good and very popular resource that you can just search in YouTube for that. There are a couple Discord servers related to Actor Framework, and the easiest way to find these is to go to labviewwiki.org and just search for Discord. And I think the top result is a list of community-managed Discord servers, 2 of which are those there. There's the Actor Framework Guild, which is a place where people can talk and collaborate on different tools and utilities built around Actor Framework to make certain aspects of it easier or more convenient. So stuff like Bowser has been discussed on there, which we mentioned previously. And also there's a Discord for the NI open source effort for Actor Framework. and as well as some of the other open source initiatives that are going on at NI. And finally, presentation link. This presentation, the slides for this, we gave them to the NI folk, but also the PowerPoint itself is in the repo along with the code, which is at that URL up there. So, anybody need more time to take a picture of any of this, or good? Cool. Yeah, Dan and I are both open for questions right now. So,
Yeah. It's a race.
So when you send a message to one of your actors, if that thing that you asked it to do, like take data from a DAC, if that takes a couple of seconds, that's not holding up the loop that you called that message in, right?
right, it's a totally different loop. It's a different, yeah.
And if you send another thing before it's done, does it have like a queued state machine? It has a queue that it's gonna go through?
Yep.
Okay,
Yep.
and then is there any way to interrupt or put something on the front of that queue instead of the back?
There's a priority as far as the queue, so you can by default it's at normal priority. You can also set it as low or high. High would be kind of the equivalent as putting it at the front of the queue. That sort of goes to best practices, I think, a little bit. I would recommend just breaking up the code into smaller messages so that you don't end up in a situation where you need to do that. That's a little bit more of an advanced topic, but the short answer is yes, you can put stuff on the front of the queue.
When there's an error, and I guess in the loop that it's running always, how does does the error come out of the main block, that one that you had at the end of the VI? And you would have to catch that error and go back into the call, or how would you finish it?
Yeah, so in the acquire VI that we had up there, if an error goes out on the error out terminal, it'll get caught by the framework, and there's actually a handle error VI that gets run.
One of the overrides those fundamental actor methods that I mentioned that I didn't override but was in that list is called handle error, and that's where you can override that behavior to do whatever you want. Make it like a pop-up dialog, log it to disk, whatever you want to do.
I guess if you're looking for, as you're building a bigger system, would you have to make that a case structure just for the error codes that you're looking to screen and actively, but still feed it back so that after you're done processing whatever that error needs to do, you come back to the loop state? Or I don't understand what.
Like if you want to come back to try and recover from the error or something like that? Yeah, so how you might want to handle that, one option would be, in your handle error VI, that gets called when an error actually happens, and then maybe you would send a message back to your own actor, that's recover from error, right? Okay. So you've got the loop sitting there running, you want to do something different now, right? You want to recover from the error. So you create a method for that and create a message for it, and then just send yourself the message. And it can do the recovery.
Well, one key thing there, as long as you handle the error and then don't pass that error out through, the loop will continue running. If for some reason you pass the error out, again, the default behavior of the actor framework is to shut down the actor, which can be a little bit confusing at first. There are reasons why that implementation was chosen. Beyond the scope of this present.
Yeah, and it's a default. You can very easily change it to make it do something else. I always change my actors so that if they get an error, they try and fix it themselves, not shut down. So you can do whatever you want. But it is good to know that, if you start running an actor and it throws errors, it will shut itself off.
Yeah. Let's say you have applications that are based on the queue message handler and you want to convert them to actor framework. Are you better off starting from scratch, or can you modify them?
So you already have one that's built up using a QMH and you want to convert it to actor framework? That's an interesting question. I'd say that's a good opportunity to suggest a tool in the actor framework guild for something that could do that. There's currently not a way that I'm aware of that automates a conversion of a existing QMH that has all those cases and everything to actor framework. So in that case, it might just need to wait until you start a new application to build it from in actor framework.
I mean, you could manually do it, but depending
Yeah,
on how
you can
complex your
manually do it,
application is, it could be time consuming. It would be a super cool tool.
Yeah, if you already have like sub-VIs in the case structure that do the thing, then it'd be a lot easier to convert to active framework because you already have the methods.
So have you found where there's maybe a limit on how many states you have, so how many actors you have, and when it becomes like unmanageable in your project view? Or is that, or do you have a tool, besides, because as you add more states, your project is going to grow. Your project view, you're going to have a ton of information there. So if I have a project that has, or a queue message handler that has, say, 100 states, is that going to become a problem, with the actor framework in a...
I think it would become a problem in that it's hard to find everything, but I think you also have a problem in the queued message handler. If you click on the case thing and you have a ton of those. My advice there would be to be deliberate about what an actor does, right? You've seen it's easy to create a new actor and spin it up. So I think if you're finding that you have hundreds of cases, there might be an opportunity there to break that into more discrete actors that each have fewer numbers of cases or methods.
Yeah, and I mean, I definitely end up just some things related to that, like organizing things into virtual folders within the actor class. Everything's in libraries, so if you have several actors in your project that are all large, you can just look at one library at a time. Actors are really good in terms of, if you set them up right, you're not going to be coupled to other parts of your code too much. So you can create some projects that are just for developing this, actor A, the one thing that has 100 cases in it, and test that by itself, and then incorporate it into the rest of your application.
Yeah. And we are 5 minutes over time. I'm happy to chat more with anybody if they have questions, but if you need to go, don't let us hold you up either. Well, thank you for attending. I hope you got something out of it.
Yeah, thanks for coming.